sorry, it says just graphing functions. Throw in the word linear there, because I guess it should be more specific. I should have been more specific. Pick in the word linear there because we're only graphing one type of function. And then there was one other mistake I caught that you can go ahead and change already. And that's down here where it says y-intercept. Change that to c over b. That should say c over b. So this lesson may be something, I don't know, close to half of you hopefully, or maybe less than this class. But you should have already started kind of graphing. Some of the concepts we're going to go over today, such as slope, I'm going to understanding that that's something that you're supposed to know coming in. Okay, if we're talking about slope, or some words you know about slope. There you go. That's the most people tell me rise over run. Maybe they don't know what that means, but like yeah, rise over run. I'm hoping you've used slope formula in order to find slope. Part of the reason why the assignment looks so long, the digital one, is because I threw in some of that review stuff on how to find slope with 2 points, how to find slope from a graph. But you know, slope is a concept you should be familiar with. What are we going to do today? Like, you know, in the English language, what do you call words that you do? No, go on. English language, forget about math right now. Right now you're sitting in your language arts class and you're talking about the types of words that describe something that you do.
Oh, adjective?
No, not an adjective. A what?
A word.
Wow. I'll give you a clue. It starts with V and ends with er.
Oh, verb.
Speak more forcefully. I didn't hear you. It is a verb. It is a verb, yeah. Okay, so what's the verb up here? What are we going to be doing? We're going to be graphing. Speaking of adjectives, here's an adjective, right? Somebody mentioned adjective. An adjective is a word that describes a noun. The noun here is functions. Okay, we're going to be working with functions. So a function is a fancy word for an equation. I mean, yeah, there's some subtle differences, but for practical purposes, for what you needed, just think of a function as being an equation, which that you already know, right? What does an equation have? What symbol do you see in an equation? Equal sign, right? So you're going to see an equal sign. We're working with functions. The difference is that a function versus the equations that you're used to is going to have 2 variables. But now everybody here was introduced to functions. That's the one that you took the quiz on Friday, but then if you were with Paige, you were supposed to take the quiz yesterday. So you know what a function is, right? Like, and what are those 2 variables that don't always have to be, but usually appear when you're talking about functions? What are the 2 most common variables? X and Y, sure, right? And that's why when we graph, we have an X and Y axis, which you should also be familiar with. So what I want to focus on is that adjective linear. What does it mean, linear? That's actually an adjective you should have heard already this year. You should have heard it with polynomials. And I know that you covered polynomials because on the grades that I'm putting in, you had a quiz on polynomials, you had a test on polynomials. So you should have seen the word linear before, you should have heard the word linear before, and you probably should have heard it again during equations. If I ask you what the word linear is, you should be able to tell me. And I asked earlier this morning to a different class and I heard crickets, but you guys are going to change that. What does it mean in algebra when you use the adjective linear? I understand that line is the root of the word linear, but at least you tried. Nobody linear? Yes? Linear means first power. What you should have learned with polynomials is that if you have a polynomial where the biggest exponent is a 1, you call that polynomial linear. There's quadratic polynomials, cubic. You guys did not go over that vocabulary? Cubic, linear, quadratic. Never heard those words before. Okay. So, well, luckily now you have a teacher that showed you what that means. So, linear means biggest exponent is a 1. When a power is 1, you don't see the power. You just don't write it. Okay. So what are you gonna see in this lesson? You're just gonna see the variable. What variables would that be? X and Y, right? Okay. So we're gonna see X and Y. And because the exponent is just a 1, that's what makes it look like a line, hence the word linear. When we graph, because graphing is visual, what are you gonna see graphed? You're gonna see lines. I'm just explaining to you what makes it look like a line. Most of Algebra 1 is linear algebra. The exponent stays as a 1, but later on we'll get into quadratics. That's always a fun thing. That's probably the hardest part of Algebra 1 is we get into quadratics and factoring. All right. So we broke the lesson up into 2 parts. Today we're going to graph. Tomorrow we're going to write. That's why that front page look the same on both of them. But today we're going to focus on graphing. So this front page here that looks the same on both, I'll spend more time on it today, but tomorrow I'm really not going to spend too much time on it. Tomorrow I'm going to fly through it. So when you're given these functions, when you're given these equations, the way that it's arranged, the arrangement of where you put the x, where you put the y, versus where the equal sign is, that's called a form. And there's 3 main forms. The first form is probably the most common, and that's called slope-intercept. You may or may not have heard of y equals mx plus b. I know some teachers were ahead of others, but I'm hoping at least you've seen that one. If every linear function is going to have a y, an equal sign, and an x, at least at the beginning, what makes this different? If every form has a y, an equal sign, and an x, what makes this form different? What's not in a box? M and B, yeah, right. But now when you see an actual equation, you're not going to see an M and a B. There's going to be numbers in those positions. But yes, that's what makes this different, is that we have an M and a B. Where is the M located? It's in front of the X. What do you call a number that's in front of a variable? Coefficient, very good. So the coefficient of X, Jair, could this be maybe why you didn't understand the stuff before? Because you were doing other things when the teacher was explaining? Nah, you see what happened is, so the coefficient of x, that ends up being the slope. Now some people will say, oh yeah, well that's easy. Just slope comes before x, and then the y-intercept comes after x. Well, that's a little bit of an oversimplification. Okay? Slope is the coefficient of x, it's being multiplied. The y-intercept is a constant, it's just the number. It's not going to be attached to a variable. It's just a number. And it could be being added or subtracted. Either one. But again, when you see an actual function, you're not going to see an m and a b. So really, when you look at a function, how do you know that you can identify it in slope-intercept form? There's 2 main things you want to look at. Y is by itself, y is isolated. These are the things that you hear that you don't see. So to make you see it, you want to write it. It'd be a good idea. I gave you plenty of space to write in there. So that later on when I ask you, hey, what form is this in? And you're going to say, hey, slope-intercept. And I'm going to say, well, hey, why is that function in slope-intercept? You're going to say, because Mr. Romero, the y is by itself, the y is by itself, the y is by itself, the y is isolated, and there's also no parentheses. If you don't see any parentheses and y is by itself, you can consider that to be in slope-intercept form. We talked about the things that we're going to be doing in the next 2 days. Today we are graphing. This is more of an opinion. I think it's kind of a widely accepted opinion, but it's more of an opinion that of all the 3 forms, slope-intercept is the one that's preferred for graphing. When you graph, more often than not, you're graphing out of slope-intercept form. If I ask you what values can you easily identify when a function is in slope-intercept form? Take a while, guess what those are. Y-intercept and slope, hence why they call it slope-intercept form. Sure. The second form, point slope form, I would opine, it would be kind of an opinion, it's not universally accepted, but I think it's somewhat accepted that this is a preferred method, the preferred form for writing equations. Slope-intercept for graphing, this one I think is a little bit easier to write. If every function has a y, an equal sign, and an x, what makes point slope form different? What values can I identify when a function is in point slope? You can identify the slope, which now the slope is going to be in front of the parentheses, and you can identify now just any point. Now maybe I should have spent more time on that. What is a y-intercept? It's a point. Let's talk about subject and predicate, right? A y-intercept is a point. It happens to be a specific point where a line or a function crosses the y-axis. Whereas now in point slope, you can have any point. It doesn't have to be the y-intercept. You would put the x of that point here. You would put the y of that point there. Another thing I want you to realize is what's in front of both the x and the y. A minus. That's gonna have an effect. Just keep that in mind. Just store that up here. So these are the three values that we can identify from point slope. If I ask you and you say, oh yeah, that function is in point slope, and then I ask you, well, how were you able to identify that? What makes a function be in point slope? You have a constant on the same side with a y. You're not going to see a y1. Y1 is going to be a number. You have a constant inside of a parenthesis with an x, and then the fact that there's a parenthesis there. Of all the forms, this is the only one that has a parenthesis. Now the last one is the least useful form. Standard form, well, but standard, that sounds like common, like you use it every day. It's probably, I would argue, the least useful. It isn't very beneficial for graphing. It isn't very beneficial for writing functions. But we can kind of manufacture ways to, at least a graph out of it. Writing a function in standard form would just kind of a waste of time. But if you have a function that's already in standard form, we can find ways to graph. The thing is now, look, x, y, equal sign. But now the values that will change, this a, b, and c, they don't really bear any significance. There are going to be numbers there, but the numbers by themselves don't really mean anything. But we can kind of manufacture and find ways to get what we need. Like, we're not going to be able just to see what we need, but we can still use it to get what we need, and that's where this stuff came in. So let's say I'm given an equation in standard form, and I want to find the slope. As long as I know what a, b, and c are, I can find the slope by doing negative a over b. These are the two main things that we get from standard form, the intercepts. If there is one benefit of standard form, it's easy to find the intercepts. If a y-intercept is where you cross the y-axis, what do you think an x-intercept is? Yeah, there you go. How do you find the x-intercept? C over a. How do you find the y-intercept? C over b. As long as we don't waste too much time eating crispy M&Ms, we'll be able to, they're not crispy, what are they? When we talk about what makes a function be in standard form, x and y are on the same side of the equal sign. This is the only form that has x and y both on the same side. There are no parentheses, and a, b, and c must be integers. If you don't know what an integer is, it's just not a decimal, not a fraction. That would be the best way I could explain it. Some people confuse them with whole numbers. The one difference between whole numbers and integers are whole numbers can't be negative, integers can. No, wait, I might have said that wrong. Integers can be negative, whole numbers can't. Correct. People most often confuse integers with whole numbers. The only difference is the sign. Integers are allowed to be negative and whole numbers. All right, so what do we need in order to? What are the things that we are going to do? We're going to graph, and we're going to write functions. Today, when we're graphing, at the end, we are going to produce a graph. Bam! There's going to be a graph on the paper. I gave you plenty of graphs on there, so you have all this space. We're going to start doing examples. So we're going to produce a graph, but what do we need in order to produce a graph? Yeah, well, they're usually going to give us an equation, but if they do give us an equation, what we need is slope and a point. Now, I guess technically speaking, you could also get by with a point and a point, like 2 points, but then that would kind of defeat the purpose because how many points do you need in order to draw a line? 2. So if you just put 2 points to connect the dots, there's not much work that goes into that, but typically when you graph, this is what you're going to have to find, or this is what you're going to have to work with in order to produce a graph. Now, what I'll spend more time on tomorrow, the only part I'm really going to spend on tomorrow is this part, which is what we can use to write a function. I won't waste too much time on that today because we'll do that tomorrow. But this is what you would need to write a function, and it's already conveniently on the paper, so you don't have to spend as much time writing. Okay, ready to rock? Let's do some examples. What form is this equation in? Slope-intercept, sure. Y is by itself, and there's no parentheses, right? Geez, and I'm being asked for the slope and the y-intercept. That's sure is convenient. So if I want slope and y-intercept, this is already in slope-intercept form, then in order to find, I don't really have to do much of anything other than identify. Just know where it's located. It's already being given to me. Just know how to read it. What's the slope here? -3, good. Not because it's in front of the x, it's because it's being multiplied with the x. It's the coefficient of the x. And what is the y-intercept? Remember that y-intercept is a point. So besides being asked for this as a value, you might be asked for this as an ordered pair. Because a y-intercept is located on the y-axis, what does every point on the y-axis have in common? Well, that x is 0. Is this something you went over with your teacher this year or before, like other years? That's very possible. Eating M&Ms? Skittles? Skittles are fun. Okay, now here we go. Yay, we've reached graphing. The way that we approach each graph, if we're going to be really flexible, would be to accept whatever form we're given and work within the construct of that form. So like what form is this? Slope-intercept. Now, so what can I easily gather from slope-intercept? Slope and y-intercept. But I would advise you to write it a little bit different. So like we just identified slope on the last one, and I'm going to ask you for slope again. What's the slope here? 3. But here's what I would tell you to do for a graph. Always write it as a fraction. Write it as a fraction. You're going to make less mistakes that way. So that's going to be 3 over 1. Okay. The y-intercept, I would write it as an ordered pair, as a point. 0, 4. So notice how I put on that first page in order to graph, you need a point, you need a slope. You start off at the point. It is a starting point. This point is at 0, 4. Where do I find 0, 4? 4 up, thank you. Now, see, I have a whole lecture that I could give you on just slope, how to apply slope. And really, usually as a teacher, one of the things I try to do, when time permitting, is to teach you something like if you're hearing it from me the first time. I always prefer not to have to rely on you knowing something going in, but and the way the circumstances are, I have to rely on you understanding slope. So if I were to ask you what the 4 different types of slopes are, would you be able to tell me that? Last period, somebody actually did. Can you tell me what the 4 different types of slope are? There's 4 types of slope. We're about to now. We got 1 point. How many points do you need in order to draw a straight line? Minimum 2. I'm always gonna try to do 3 points, but yes, the minimum is 2 points that you need, right? Once you have a starting point, slope is gonna help you find the rest of your points, but you have to know how to apply it. In order to apply it, you should know what the 4 different types of slope are. Positive, good. Negative. What? Zero slope. So positive, negative, 0, and well, you're the second person that says it, but it's called undefined. Well, but see, the word no to me means 0. But it's really like it should be referred to as undefined. If you wanted to think of another word, I would actually use the word infinite. Before I use the word no slope, I would say call it an infinite. So you would be more accurate to call it infinite. So the type of slope tells you what direction to go. So what type of number is 3? Positive, right? What direction do positive slopes go? Right.
Oh, yeah.
Upright, very good. Upright, down, left. Remember, as long as you have both a y and an x, you will have a rise and you will have a run. X runs, y rises. So as long as you see both of them, you have to have both movements. I've tried different ways. I've tried to have people visualize it being like a GPS and telling them when to turn left and when to turn right. I've tried different ways. It's just studying. It just comes back to studying. Maybe probably the best way I found. If you have a positive slope, both movements have to be the same. So, like, if you go up, you would consider that to be what type of a movement? Positive or negative? Positive. So your next movement has to also be positive, which would be left or right. Right. If you go down, that's fine. That's negative, but then you have to also go left. And then that's why they teach you rise over run. Don't get them too confused. So if I rise up 3 and run 1, those are your 2 points. I don't like to graph just 2 points because if I make a mistake, I won't catch it. You can always connect 2 points even if you're doing it wrong. So I like to always do a 3rd point because then if the points don't line up, I know I'm doing something wrong. Maybe I counted wrong. So if you want to just go up 3 and right 1 again, you can do so. Or you have the option of going down 3 left 1, down 3 left 1. You keep on going, you can impress all of your friends with all the points that you're putting on the plane. And whether you do 2 points, 3 points, 4 points, 5 points, if you do it correctly, what should they all do? Yeah, they should line up. Another thing that they should do, but I don't really expect you to do this every time. It's just a cool party trick if you want to show our friends. You can also substitute any of these points into the equation, and you should end up with 2 equal sides. This one here, where you get the point and you substitute them in. So, like for instance, I was able to find through slope. I didn't know this before, but now through using slope, I know that -3 and -5 are part of this line. You would agree? You have it in front of you on your paper. It's going through there. Let's see what happens when I put in a -3 for x, because -3 is the x. What is 3 times -3? -9. Plus 4? It's okay. We're your support group. We're here to help. What form is this in? Slope intercept. So I can easily go a little faster this time. I can easily identify slope and y-intercept. I'm going to start my graph at the Nakai, right? I'm gonna start at y-intercept of 0, -5. I still understand rise and run. I can still rise. I can still run. Me preference. It's just a preference. I like to try to stay close to the origin. So if I'm starting below the origin, I like to go up. If I start above the origin, I like to go down. If I'm around the origin, I'll do one of each, up and down. But it's up to you. Do whatever makes you feel comfortable. So I can go up if I want. Just make sure that I'm going up 3. And once I go up 3, where should I go next? Yeah, good. Left. As Beyonce once said, you go to the left. Should I teach you a way to remember it? So I told you if you have a positive slope, make sure both movements are the same, either both positive or both negative. If you have a negative slope, one of the movements has to be negative. So if I chose to go up, that's positive. Where should my next movement be? If one of my movements has to be negative on a negative slope, and I chose to go up, then yeah, I gotta go negative, which is left. If I start to choose going, like if I choose going down first on a negative slope, I already used up my negative movement, so I have to go right next. You do as many as you want. I like to do 3. Somebody asked me last period, oh, does your line have to take up the entire graph? No, just as long as it's clearly going. Oh, wow. Perfect. I love the fact that I did. Look at that. Uh-huh. And I didn't even do that on purpose, to be honest, but I'm glad I did. Because look at that. I counted wrong. How did I catch my mistake? I'm trying to get these points to line up, but geez, they don't line up. Well, Mr. Romero, it's not fair. You have a computer. I don't have a computer. Well, what do you have? Yeah, a ruler, a straight edge. I'm talking about a straight edge. Look, I counted wrong. The first one I did was correct, but then I went up 3, left 2, but then the next time when I went up 3, I only went left 1. I caught my mistake. Well, I guess I made the mistake afterwards, but whatever. If I would have made the mistake first, I would have caught my mistake. So, another thing I would advise you to do, it's like, long ago when teachers had more power than students, I used to like mark things wrong if the kids wouldn't follow directions here. I've given that up, but at the very least, if you want to help yourself, because sometimes people put graphs that are kind of questionable, and it's like, where is that going through? So if you want to help yourself, label these points. If your line looks a little bit off, but then you clearly tell me, you state to me that this is -4, 1, this is -2, -2, this is 0, -5, I'm much more likely to go on your side of things than on the other side. Yeah. Too long. 15 years is my 15th year. Thanks, man. I appreciate that. You too. Okay, here's another one. What? What form is this in? It's also slope-intercept. Well, wait, Mr. Romero, I do not see a y-intercept. It's slope-intercept because y is by itself and there's no parentheses. The slope is 2 over 1. What's the y-intercept? 0, 0. Good. This is going to go through the origin. Shobi, once I start at the origin, where do I go next? Show. How far? 2. Good. And then where do I go next? Good. And if you really like that, you want to do it again, do it again. If you don't like that, you want to go the other way, you can go down 2 as long as you go. Go down 2 as long as you go. Connect the dots, and then you celebrate. It'd be a good idea to label your points. So like this is Algebra 4, this is 1, 2, this is 0, 0. Aight. Let's do 5 more. Got 10 minutes. What form is this in? It's standard form, all right? So, really, like standard form, you don't really like the graph out of it, and if you're gonna write an equation, usually you're trying to get out of standard form. Like tomorrow, what we will do a lot of is taking standard form and changing it to slope-intercept. But if you were to graph, one of the things standard form is good for is to find intercepts. So I would tell you, like on these, I probably would just only graph 2 points, and those 2 points would be the x and y intercept. And I even gave you a shortcut for finding those. So, oops. Every x-intercept has a 0 for y. Every y-intercept has a 0 for x, right? What did I tell you was the shortcut for finding the x-intercept when you're in standard form? On the first page of the notes, what is the shortcut for standard form finding the x-intercept? Just say it again. No, for the x-intercept? C over A. This is A, this is B, this is C. So what's C? What is C? 18 over A, which is, what was the shortcut I gave you on the first? That's the one that we had to fix. Well, this one is what? C over y-intercept of C over B. That's the one I told you to fix. I made the mistake on the original copy. I asked you guys to fix it. Y-intercept C over B. 18 divided by 6 is 3, 0, 0, -9. We have our 2 points. We're excited. Just graph them and connect the dots. 3, 0, 0, -9. And now we just graphed out of standard form. I would say that would be the preferred way. Like standard form, yeah, like if you're given standard form, that's the quickest, the easiest. That's what's going to make your life easier. But I'll give you one other option. What's the next problem? So write it bigger. I gave you plenty of space. On the graph, you know? Yeah, just count, man. Come on, you have to charge them up. I lost my charger. Okay, here's another equation in standard form. To be very honest, if I were to graph this, I'd do it again. This is the way I did it before. Just find the 2 intercepts and connect the dots. But just to give you some other way of doing it, let's do this the way we did before, which was with slope and y-intercept. What was the shortcut I gave you for slope in standard form? I gave you a shortcut for slope in standard form on the first page. You read it to me. Negative A over B. So that would be negative 3 over 2. What was the shortcut I gave you for y-intercept? What was the shortcut I gave you for y-intercept? C over B. Negative 6 divided by 2 is negative 3. So if you're not paying attention now, you can always go back and watch the video. It'll be on there by today. Today after school, I'll upload it.
How long did it take you to upload?
5, 10 minutes.
I really like that whole.
Whatever, well, yeah, whenever you see this on, that's because I'm recording.
How many subscribers?
A billion.
More than
So negative slopes, what direction do negative slopes go? Up left, down right. A, B, select start. Up, down, left, right. Oh, look. Actually, no, never mind. That's just, I did it right. I thought I had made a mistake. If I had more time, I would label. Any questions there? 3 more. We won't get through all of these, but we'll get through enough where I'm hoping you have somewhat of an understanding. What form is this in? No. This is point slope, which is not ideal for graphing, but you can graph out of it. Where do you find the slope in point slope? In front of the parentheses, this slope is 2 over 1. Where do you find the point? The x of the point you find in the parentheses. Remember that negative I told you to pay attention to? Remember that negative in the formula? Well, what that negative really causes, the easiest way I can describe it, is you got to change the sign. So like when you look for the x, you look inside the x and next to like in the parentheses, the next to the x, you see a -1. That means the point on the graph is going to be a positive. You look in the equation and next to the y, you see a +3. It's really going to be a -3. That's caused by that negative in the formula that I pointed out. I guess for now, just take my word for it. So instead of starting on the y-axis, where am I going to start here? Where should I place my first point? At 1, comma, -3, 1 to the right, 3 down. What direction do positive slopes go? Upright and down left. 2 up, 1 right, 2 up, 1 right. You look like a beet. Like a beet. I think that's a type of vegetable. I don't care. It's fine. All right, the last two. What do you see different about this one? There's only one variable. So watch, you might want to listen to these. These will give you some free questions, maybe on a quiz or a test. These are the easiest ones we've done all day. When you try to graph only one, which one is this one missing? The y. When you try to graph one variable, it's either going to be horizontal or vertical. So it's just about memorizing. See, that's a problem. You guys see the x and you think x-axis, but it's backwards. So the way I've had the most success teaching this, okay, you want to think of x-axis? Fine. Find -3 on the x-axis. But then think to yourself, well, you know what? If I drew a horizontal line through it, I'd be getting all the x's. I don't want all the x's. I only want x to be -3. So it's going to actually be, and for these, you only need the 1 point. It's vertical. When you see only a y, okay, find 7 on the y-axis. Find 7. But then you're thinking, oh, y goes up and down, but I don't want to get all the y's. I only want y to be 7. So it's a horizontal line. And that's at least a little bit of variety of everything about it. So you could go home tonight and work on all the graphing problems on the assignment. Any other questions for me?